Students are able to hear me? Am I audible? Hello? Guys, am I audible?
Yes, sir.
Okay. So I'll get started. I hope you're able to see my screen also. Now see. So yesterday we started exercise 16.3, right? We solved the first problem. So let's solve from the second one onwards. There is a coin that is tossed twice. What is the probability that at least one tail occurs? Okay. So how to solve this? What is the sample space? Head, 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 tail, tail, head, tail, tail. Right? So what is the probability that at least one tail occurs? So probability of getting one head, one tail, plus probability of getting one tail, one head. Here the order is important. Plus probability of getting two tails. Right? So what is the probability of getting one head, one tail? 1 out of guys, what is the probability of getting head, tail, tail, head, plus two tails? So what is the probability of getting head, tail? How many such
1/4.
events? It is 1/4. Equally likely events. Tail head is 1/4. Tail tail is 1/4. Answer is 3/4.
3/4.
Okay, this is the answer. But what is the alternate way to solve this? So I can write probability of at least one head, one tail only, no? Yeah, at least one tail is equal to 1 minus probability of getting no tails. They both are same. So what is the probability of getting at least one tail? 1 minus. What is the probability of getting no tails? Means getting both as head. How much is that? It is
1/4.
1/4. So 1 minus 1/4 is 3/4. So whether you do it in this way or this way, your answer is the same. So whichever is comfortable to you, you can use it. As long as you are clear with the concept. Or the third way is to solve what? Getting at least one tail is equal to head tail, tail head, tail tail. Correct? So that is the number of elements in this, that is 3 out of the number of elements in sample space, that is 4, 3/4. This is also another way. Guys, I hope all the methods are clear.
Yes, sir.
Yes. So I'm proceeding with the next problem. A die is thrown. Find the probability of the following events. A prime number will appear. Guys, if you have more discussion, it will be better. You can participate and you can say. So I'm saying a prime number will appear when a die is rolled. What are all the prime numbers that you have? So sample space is 1, 2, 3, 4, 5, 6. Then event A is what? Only prime numbers to occur.
1, 2, 3,
2,
and
3, 1.
2, 3, 5, sir.
2, 3, 5, sir. Sorry.
Yes. It is 2, 3, and only one die is rolled, no? 2, 3, and 5.
Yes, sir.
What is the probability of A? It is the number of elements in A divided by the number of elements in the sample space. That is 3 out of 6.
1/2.
It is 50%. Second, what is event B? A number greater than or equal to 3 will appear. It is 3, 4, 5, 6. So probability of B is number of elements in B by n of S. That is 4 out of 6,
4
which
by
will be
6.
2 by 3. 2 by 3. Correct? Next. A number less than or equal to 1 will appear. It is only 1. So probability of C is 1 out of 6. What is D? A number more than 6 will appear. It's a null set. So probability of D is 0 because it's an impossible event. A number less than 6 will appear. 1, 2, 3, 4, and 5. So what is the probability of E? It is 5 out of 6. So it's a simple problem actually. Right? Shall I move on to the next one? Next. A card is selected from a deck of 52 cards. How many points are there in the sample space?
52.
How many
sir.
sample points? It is 52, that's it. Number of elements in the sample space is 52, that's it. So this is over. Next, calculate the probability that the card drawn is an ace. So event A, how many ace do you have?
4, sir.
Oh,
Sir,
sorry,
they've
they
given
wrote-
ace of spades, sir.
Yeah, sorry, I didn't read it properly. So ace of spade is going to be 1 only.
1 by
Number of
52.
it is 1. Number of elements in sample space is 52. So probability of A is 1 out of 52. Okay. What about calculate the probability that the card is an ace?
4 by
4 by
52, sir.
52.
Card is an ace. Only one card is selected, no? Okay. So it's not a sequential process. So probability of B is 4 out of 52. That is 1 by 13. What is the probability that it is a black card?
26 by
26 by
52.
52.
So number of elements in C is 26. So probability of C is 26 out of 52, which is 1 by 2. That's right. That's it, no? Anything else? Yeah. So there is also a simple one. It is 1 by 2. So I'm moving on. A fair coin with 1 marked on one face and 6 on the other, and a fair die are both tossed. See here, there is a coin that they have. It doesn't have heads and tails. One side of the coin has 1 and the other side of the coin has 6. And a fair die are both tossed. Find the probability that the sum of the numbers that turn up is 3. So can you tell me what is the sample space for this problem?
1, 1, 1,
Yes.
2, 1, 3.
So Toyn can
1,
show, yes, 1, 1, 1, 2, 1, 3, 1,
1,
4.
4, 1, 5, 1, 6.
Can I write it as 6, 1 also?
Yes, sir.
Yes, sir.
Okay. Tell me. 6, 1.
6, 2,
Till
6,
6,
3.
In this place, instead of 1, 5, can I write it as 5, 1?
No, sir.
Why?
1 is
Because,
for the coin,
1
1
and
and
6.
6.
Because it's an ordered pair. They have followed an order. So you don't swap it. Okay. Number of elements in the sample space is 12. Okay. So sum should turn up as 3. Let A be the
Only
event
one
where
possibility.
sum is 3. So where is it? That is 1, 2. So probability of A is number of elements in A divided by n of S. That is
1 by
1 out
12.
of 12. Yes. The sum turns out to be 12. That is also the sum is
1 by
12.
12.
So 6, 6. So probability of B is, that's right. Number of elements in B by number of elements in sample space. It is 1 out of 12. Okay. Excuse me. Okay, going to the next problem. There are 4 men and 6 women on the city council. If one council member is selected for a committee at random, how likely is that to be a woman? So, what is the number of elements in sample spaces?
10, sir.
10, sir.
Yes, it is 10. Okay. What are they expecting? A should be an event where the selected person is woman.
6
So number
by
of
10,
elements in
sir.
A will be 6. That's right. Probability of A will be 6 out of 10. It will be 3 by 4. Next. A fair coin is tossed 4 times and person will win rupee 1 for each head and lose rupees 1.50 for each tail that turns up. From the sample space, calculate how many different amounts of money you can have after 4 tosses and the probability of having each of these amounts. So fair coin is tossed 4 times, sir. So what will be the sample space? Head, head. So I have to sit and write how many outputs. 2 power 14, 2 power 4. That will be 16 outputs.
16.
Okay. But here the advantage is I don't. So what are they asking from the sample space? Calculate how many different amounts of money you can have after 4 tosses and probability of having each of these amounts. So I need the sample space. Head, 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 tail, 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 head, head, tail, tail, head, head, tail, tail. Okay. Tail, 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 8. Head, 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 tail, 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 head, head, tail, tail, head, head, tail, tail, head, tail, head, tail, head, tail, head, tail. Okay, so what are all the possibilities? You can get all 4 as hits. All 4 tosses as heads. Right? So all 4 tosses as heads, how many times is it possible?
1 time.
1 time. So if you get a head, how much is he going to win? So it will be 4 rupees. 3 heads, 1 tail. So 3 heads means 3 into 1 plus 1 into 1.5. How much is this? 3 plus 1.5, 4.5. But how many times can you get 3 heads and 1 tail? 3 heads, 1 tail, 3 heads, 1 tail, 3 heads, 1 tail, 4, 4 times you can get. So that will be 4. So 4 into 3, 4 into 4.5 is going to give you. Oh, that is, and lose 1.5. Sorry. Minus 1.5. So 4 into 3 minus 1.5, that is 1.5. How much will be the answer? Wait. So in whatever order you are going to get, 3 heads means you're gaining 3 rupees, minus 1 tail means you're losing 1.5. It will be 1.5 rupees. I'm sorry about it. It's not about the number of times. Suppose I get 2 heads and 2 tails. What will be the answer? 2 minus 3. There is a loss of 1 rupee. If I get 1 head, 3 tails. 1 minus 4.5, there will be a loss of minus 3.5. If I get all tails, what will it be? Minus 6 rupees. So there will be a loss of minus 6, correct? So what is the probability of getting all 4 heads? It is 1 out of 16. So that is the what are they asking? What is the probability of having each of these amounts? So the probability of the person to gain 4 rupees is 1 out of 16. What is the probability of the person to gain 1.5 rupees?
Three by 16, sir.
Let me check. How many times is it coming? So probability of getting 3 heads and 1 tail. Out of the 16 chances, how many times is this happening? 1, 2, 3, 3, 4. It is happening
4, sir.
4. It is 1/4. So there is a 25% chance for him to gain 1.4 rupees. What is the probability of getting 2 heads and 2 tails? Two heads, 2 tails, I'll put it in green. 1, 2, 3, 4, 5, 6. Right, that is happening 6 times. So 6 out of 16, that will be 3 by 8. What is the probability of getting 1 head and 3 tails? Probability of 1 head, 3 tails. I'll use another color, see. 1 head, 3 tails. 1, 2, 3, 4. So it will be 4 divided by 16, which is 1 by 4. Probability of getting no heads means all are tails. That is loss of 6 rupees. When will this happen? 1 out of 16 times. Is it clear, guys? Is this clear?
Yes, sir.
Please make a note. If there is any doubt, get it clarified. So if you're done, I'll move on to the next problem. So 3 coins are tossed once. Find the probability of getting 3 hits. Write down the sample space. Can someone tell me what is the sample space? Head, 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 head. Tail, 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 tail. Head, head, tail, tail. Head, head, tail, tail. Head, tail, head, tail. Okay. So 3 coins are tossed. Find the probability of getting 3 heads. Tell me, it is occurring 1 times out of 8 times.
1 by 8.
Yes. Probability of 2 hits. 1,
3 by
2.
8.
It is 3 by 8. Probability of getting at least 2 hits.
4 by 8.
4 by 8. 1 by 2.
How did you get?
1 by 2.
The probability of 2 heads is 3, sir. And then above 3 would be everything as heads, so it would be 4.
What about probability of getting only 1 hit?
They said at least 2 heads.
At least
So
2 heads.
minimum will be 2.
Oh, at least 2, no? Yes, 3 by 8 plus 1 by 8. It is 4 by 8, which is 1 by 2. What is the other way of doing it? That's more important for me, how you're thinking. So probability of at least getting 2 hits is probability of getting no hits minus probability of getting.
Should be probability of getting maximum 1 hit, sir. 1
That is
minus
1
probability
minus
of getting maximum 1
getting
hit.
maximum 1 hit, at most 1 hit. If you do this, you should still get 1 by 2. You can do it as a part. Okay. So at most 2 hits. That is probability of getting 1 hit plus probability of getting 2 hits. So probability of getting 1 hit is how much? 1, 2, 3. 3 out of 8.
4 out of 8.
No, 1
Yes,
hit,
sir. 3.
1 hit.
Okay, yes, sir.
3 by
It's
8.
3 out of 8.
The probability of getting 2 hits is also 3 by 8. That will be 6 by 8. That is 3 by 4. There is 75% chance of it.
I have a doubt, sir. At most 2 hits means. Okay, sir. No,
Oh,
clear.
no. But yeah. I missed something. I'm sorry. At most 2 hits means I can get 1 hit or 2 hits. Also, I need to include getting no hits, no? What is the probability of getting 0 hits? That is 1 out of 8. So
7
answer
by
will be
8, sir.
7 by 8. No hit. Probability of getting no hit. Right? That's very simple. It is 1 out of
1
8.
by 8.
3 tails is the same as getting no hits. That is also 1 by 8. Exactly 2 tails. Exactly 2 tails. How many are there? 1, 2, 3. 3 by 8. No tail. No tail means all are hits. 1 times you get all hits. 1 by 8. At most 2 tails. See, at most 2 tails and at most 2 hits have the same possibility. That will also come out as 7 by 8. I hope you understood how I wrote 7 by 8 directly.
Yes, sir.
Yeah, here I got 7 by 8. Same thing will be for 2 tails also. This is a very, very simple problem. If 2 by 11 is the probability of an event, what is the probability of event not a? Probability of A dash is 1 minus probability of
2 by 11.
9 by 11. 1 minus 2 by 11, which is 9 by 11. Moving on to the next one. This is a good one. A letter is chosen from a random, chosen at random from the word assassination. Find the probability that the letter is a vowel. So number of elements in the sample space is how much?
13, sir.
Yes, it is 13. Let A be an event of getting vowel. So how many vowels are there?
5, 6, sir. Oh, 1 second.
Count it. 1,
6,
2,
sir.
3. 3 A's, 2 I's, 1 O. It is 6. So what is probability of A?
6 by 13.
That's it. B is getting a consonant. That is 1 minus 6 by 13. You can either count the number of consonants or you can do 1 minus probability of no consonant. So 1 minus 6 by 13 is also 7 by 13. Okay. In a lottery, a person chooses 6 different natural numbers at random from 1 to 20. And if these 6 numbers match with 6 numbers already fixed by the lottery committee, he wins the prize. What is the probability of winning the prize in the game? In a lottery, a person chooses 6 different natural numbers from 1 to 20. Okay. And if these 6 numbers match with the 6 numbers already fixed by the lottery committee, he wins the prize. What is the probability of winning the prize in the game? So 6 numbers means how much is it in?
Is it 6 by 20?
It is not 6 by 20, no?
So it will be with 1 till 20. 1, comma 1, comma 1,
See?
comma 1, comma 20, and like that till 20, comma 20, comma 20.
Okay, but it is not possible for us to write like that, no? So how many numbers are there from 1 to 20?
So can we use permutation and combination?
You
for
need
this?
to. There is no other option. You have to, because the numbers are big, no? So from the 1 to 20 numbers, you are choosing any 6 numbers, right? So let's say, see, the lottery ticket will have 1, 2, 3, 4, 5, 6, 6 blank spaces. And in those 6 blank spaces, you can have any of the 20 numbers. My question is only about repetition or not. I'm assuming it is without repetition. So what are the total number of ways to choose 6 numbers from 20 numbers? You have 20. From 20, you're choosing 6. Can I write it as 20C6?
Yes.
Right? So they told order of the numbers is not important. Okay. Let me read the question again. What is the prop? And if the 6 numbers match with the 6 numbers already fixed by the lottery committee, he wins the prize. Means, see, suppose the numbers he's getting is 2, 3, 4, 5, 6, 1. If suppose he has the numbers 1, 2, 3, 4, 5, 6 also, he's going to win. That's what I'm able to understand. Wait. No, that's not the thing. That's not the thing. So a lottery ticket number, okay, the winning prize is possible by how many tickets? There will only be one ticket that can win. So out of the 20C6 combination, there is only one ticket that is going to win. Let A be the event of winning the lottery. Then probability of A will be how much? 1 out of the 20C6 ways. That's the answer. Guys, did you understand what happened? Is there anyone having a doubt? Are you able to hear me?
Yes, sir.
Okay. So no doubt, right?
No doubt, sir.
No, sir.
Check whether the following probabilities P of A and P of B are consistently defined. P of A is 0.5, P of B is 0.7. P of A intersection B is equal to 0.6. So how do I check if it is consistently defined? Let's see. See, probability of A is nothing but number of elements in A divided by number of elements in sample space. Probability of B is the number of elements in B divided by the number of elements in sample space. Probability of A intersection B is number of elements in A intersection B by N of S. So this is 0.5, 0.7, 0.6. So number of elements in A is 0.5 times the number of elements in sample space. Number of elements in B is 0.7 times the number of elements in sample space. Number of elements in A intersection B is 0.6 times the number of elements in sample space. Now understand one thing. Number of elements in A is 0.5, but the number of elements in A intersection B is 0.6. Is this possible? Is this possible? Since probability of A is greater than probability of A intersection B, sorry, less than, it is not consistently defined. Okay. What about the other one? P of A is 0.5, P of B is 0.4, P of A union B is 0.8. This is possible. Because when you write A union B, you will write the number of elements in A and number of elements in B. That is possible. Okay. Since P of A union B is greater than P of A and P of A union B is also greater than P of B, it is consistently different.
Understood.
Okay. Next one is very simple. P of A is 1 by 3, P of B is 1 by 5, P of A intersection B is 1 by 15. How to solve this? So what is the formula for P of A union B? It is P of A
P of A plus
plus.
P of B minus P of A intersection.
So for the first one, it is 1 by 3 plus 1 by 5 minus 1 by 15. That is 8 by 15 minus 1 by 15. That will be 7 by 15. Right? Here it is 0.35, 0.25. And this is 0.6. For the second one, 0.6 is equal to 0.35 plus probability of B minus 0.25. So what is probability of B? It is 0.6
0.6 by
minus 0.5.
Yes, sir.
Yes. What about the third one? Third one is 0.7 is equal to 0.5 plus 0.35 minus zero 0.5 or 0.5. How much is it?
0.5, sir.
0.15. So P of A is 3 by 5, P of B is 1 by 5, P of A or B, if P of A intersection B are mutually exclusive. So since P of A intersection B is 0, P of A union B will be equal to P of A plus P of B. How much is that? 3 by 5 plus 1 by 5, that will be 4 by 5. So E and F are even such that P of A is 1 by 4, P of F is 1 by 2, P of E and F is 1 by 8. Find P of E or F. So what is P of E? 1 by 4, P of F is 1 by 2 minus 1 by 8. So 1 by 4 plus 1 by 2 is 3 by 8 minus 1 by 8, which is 2 by 8. Or it is 1 by 4, correct? Similarly, find of P of not E and not F. So that is nothing but guys, did you understand? P of not E intersection not F is nothing but P of E union F the whole dash. This is according to De Morgan's law. Okay. P of E union F the whole dash is nothing but 1 minus P of E union F. 1 minus 1 by 4, which is 3 by 4. Guys, are you able to understand?
Yes, sir.
Okay. So E and F are such that P of E dash intersection F dash, that is P of E union F the whole dash is 0.25. There's nothing but 1 minus P of E union F. State whether E and F are mutually exclusive events. So for them to be mutually exclusive events, what should have happened?
Intersection F should be 0.
Should be null set. But what is P of E intersection F? It is P of E union F. Okay, let's do it like this. What is P of E union F? P of E
0.75.
plus P of F minus P of E intersection F. Extremely sorry. E dash union F dash will be, I made a mistake actually. E intersection F the whole dash, that will be E union F. Sorry, intersection. So I didn't see the word or. So they told it is unlike the previous question, it is and. I thought it's similar. Here it is or no. So P of E dash union F dash is equal to P of E intersection F the whole dash, which is 0.125. P of E intersection F the whole dash is nothing but 1 minus P of E intersection F. So 1 minus P of E intersection F comes out to be 0.25. So what is P of E intersection F? That will be 0.75. Since it is not equal to 0, they are not mutually exclusive. Answer is no. Okay. A and B are even such that P of A is 0.42, P of B is 0.48, P of A intersection B is 0.16. Determine P of not A. So P of A dash is 1 minus 0.42, that is 0.58. P of B dash is 1 minus 0.48, that is 0.52. P of A or B is equal to P of A plus P of B minus P of A intersection B. What is P of A? 0.42 plus 0.48 minus 0.16. 0.48 plus 0.42 is 0.9 minus 0.16 is how much? 90 minus 16 is how much? 74. So it is 0.74. I think all the problems are formula based. I hope you can do it. Okay. Anyways, 3 more round, we'll complete. So in class 11, a school of 40% of the students study mathematics. So probability of mathematics is 4 out of 10. Because 4%, no, 40 by 100. Probability of biology is 30%. And 10% of the class study both mathematics and biology. So probability of maths and biology is 10%. If a student is selected at random from the class, find the probability that he will be studying maths or biology. The same problem. P of M plus P of B minus P of M intersection B. So P of M is 0.4 plus P of B is 0.3 minus 0.1. So 0.6. Next. In an entrance test that is graded on the basis of 2 examinations, the probability of a randomly chosen student passing the first examination is 0.8. And the probability of passing the second examination is 0.7. Probability of passing at least one of them means F or S is 0.95. What is the probability of passing both? F intersection S is equal to what? Same formula you people calculate. Is there? I hope it is clear, guys. So I'll directly do it. 0.95 is equal to 0.8 plus 0.7 minus probability of F intersection S. So probability of F intersection S is 1.5 minus 0.95. So it is 0.55. So probability that a student will pass the final examination in both English and Hindi is 0.5. Probability of passing neither of them is 0.1. The probability of passing English examination is 0.75. Find the probability of passing Hindi. So 0.1 is equal to 0.75 plus probability of Hindi minus 0.5. So it will be 0.25 plus probability of H is 0.1. Are you getting a negative value?
So I don't think P of E union H is 0.1. So
The probability of
P
passing
union
either.
H dash
Oh, E
is
union then
0.1.
H the whole dash. Yes, yes. Because I'm getting a negative value. That's right. So P of E union H the whole dash is 0.1 means so what they are trying to say is probability of failing an E and H is 0.1. That is probability of E union E dash union H dash.
It should be P of E union H the whole dash. So
Wait, P of E union H the whole dash is nothing but 1 minus probability of E union H. Correct? That is 0.9, 0.1. So what is the probability of E union H? That will be 0.9. Now you will get 0.9 is equal to 0.75 plus probability of passing in Hindi minus 0.5. So 0.15 plus 0.5 is equal to probability of H. That will be 0.65. Right? So if you observe, all the problems are in this similar to the last exercise of sets, the first chapter.
yes, sir.
Everything will be similar
Yes,
to
sir.
that. So in a class of 60 students, 30 opted for NCC, 32 opted for NSS. So probability of NCC is 30. Probability of NSS is 32. Probability of A and B is 24. If one of the students is selected at random, the probability that the student opted for NCC or NSS is 30 plus 32 minus 24. That is 38. 38.
So I have a doubt, sir.
No, 30
How can
divided
we
by
call
60.
it? Yes, sir.
No. Yeah, sorry. The whole thing divided by 60 because it's greater than 1, no? I was just looking at numbers. So 38 by 60, that is going to be 19 by 30. Correct? The student has opted neither NCC nor NSS. So probability of so that is 1 minus 19 by 30. How much is this? 11 by 30. The student has opted NSS but not NCC. Probability of A and B dash is equal. So what is the probability of A intersection B dash? I told you yesterday. That is probability of A minus probability of A intersection B. Okay. NCC is A. It's opted for NSS. So A dash intersection B. Correct? That will be probability of B minus probability of A intersection B. So what is probability of B, guys? 32 by 60 minus probability of A intersection B is 24 by 60, which will be 8 by 60. How much is this? 4 divided by 30. Or 2 divided by 15. That's the answer. Is there any doubt? Did you understand how I wrote this step? Did you guys understand how I wrote P of So answer is 2 by 15. So with this we are done. Okay. Miscellaneous is homework you people have to do, and you have to approach me if there is any doubt. All the problems are similar. Okay. There is nothing much for me to teach. Next class I will start statistics. Maximum 2 more classes we will be done. Okay. With that your syllabus will be over. So that's all from my side. Is there any doubt?
No,
No,
sir.
sir.
Chapter.
Okay. So just wait for a minute. Don't log off.